Hello students, welcome back. Now let's go to section 3, quadratic inequalities. Please pay attention here everybody. This is going to be very important to a lot of students in terms of exam preparations and grades. Why? We're going to deal with some important but tricky topic that can be done easily if you follow the proper method, but if you don't follow the proper method, then you can't. Most of the time, easy problems are easy to everybody and hard problems are hard to everybody. So each individual problems do not really make a lot of personal difference between one and the other type of students overall, but this one's different. This one's really different. Here's a motivating example. Solve a given quadratic inequality. So how do you solve it? I see this kind of answer a lot in intermediate algebra class. A lot, I mean by nearly half the class. Sometimes I've seen worse actually. Now this is college algebra, so I expect a little bit better outing, but still. So here we go. Inequality, factor it. Blue inequality or red inequality. So that blue solution or red solution. What's the problem? You just earn an automatic 0 credit. Now for equations, this is perfectly fine. We have a quadratic equation, factor it, blue is equal to 0 or red is equal to 0. So we have blue solution or red solution. This is perfect, full credit. This one, 0 credit. What's going on here? Inequalities and equations are fundamentally different. For equations, there's something called zero product property. So here, blue times red is 0. Then we have to have either blue is 0 or red is 0. There is no other way. There's no way I'm going to get 0 by multiplying two non-zero numbers. So if I product of these two, one of them has to be 0. In some case, both of them, but in this case, it's impossible to have both of them. So one of them has to be equal to 0. So we have blue is equal to 0 or red is equal to 0. Now we have inequality. This is different, fundamentally different. This blue times red is less than 0. That means blue times red is negative. Okay, how do you get negative? That means two different signs. Blue is positive and red is negative, or blue is negative and red is positive. That's how you get negative. It's not going to be this simple, so the answer is not going to be this simple. Still, I'm afraid I see this kind of answer a lot in intermediate algebra class. I hope things are better here in college algebra. Nonetheless, I'm making appropriate emphasis here. How do you do it right? My suggestion is to use graphs. Now we're going to learn a little bit more advanced method in chapter 5 when we deal with polynomials and rational functions. But for now, let's stick to graph method. Here we go. Factor it and less than 0, all right? And then instead of decomposing, blue is less than 0 and red is less than 0 like that, instead graph the function. Y equals to x plus 5 times x minus 1. So this is the intercept form. So we have the 0 at -5 and another 0 here at x equals 1. And then this y coordinate has to be less than 0, so it has to be negative. So the graph has to be below x-axis down here. So in which interval we have y coordinate going down like this? Between -5 and +1, of course. Now it's easy. If you have graph, it's easy. Okay, here's another problem. This time you need a little bit further work. The right-hand side is not 0, so flip everything to the left-hand side, take the like terms together, and then go from there. Is everybody happy with this? Flip everything to left-hand side, make it into the standard form, and then factor it. And then in the end, what do we have? Y equals 2, x minus 2 times x minus 3 is greater than 0. So y is greater than 0. What does it mean by that? Y coordinate is greater than 0. That means the graph should be above the x-axis. I want here to the left or there to the right, not in the middle. So expand to the middle part. This part, x is less than 2, or that part in the right, x is greater than 3. Putting together in the interval notation like this: negative infinity to 2, union 3 to infinity. You may have to pay a little bit of attention to this interval notation, union and things like those, but you're going to get used to this quickly. In the end, graphs really help. And when you graph, the intercept form really helps. Okay, how about the next problem here? Okay, this is going to be a little bit more challenging because compared to this one, this is going to be even more challenging because more simplification is needed. Okay, what's the standard process? Number one, denominators. Remove all the denominators, but we don't have denominators, all right? Number two, parentheses. Looks like we have to break up the parentheses. And then number three, like terms. So, break up the parentheses. Go ahead, break up. What do you get? Fall out. What do you get? Stop the playback and do it. And then check it out with the sensor key. Okay, here we go. This one, break it up, and you can fall out like this. All right, no denominator, so let's go to step 2. Parentheses, break up parentheses, here we go. And then step 3, like terms. Take the like terms together here. And more like terms in the right-hand side, so flip those over. All right. And then we have to factor it, but here I'm afraid I cannot think straight if you have negative number as a leading coefficient. So whenever I see things like that, I multiply -1 to each term and correct like this. And there, be careful, you have to change the direction of the inequality. Now, if you prefer to work with negative directly, go ahead, but that's not my style. Okay, anyway, once you have this, you can factor it. And then how to factor? Well, by now, everybody should have mastered how to factor. In case you didn't, here we go. 12 times -10 is -120, right? That -120, find factors of that -120, that'll add up to -7. Good luck. 12 times -10 is -120. Factors of -120, that'll add up to -7. 8 times -15. Now fill out all these. They're all multiplications. 4 times 2, 3 times -5 like this. And then cross multiply. 4 minus 5, 3, 2. And that's how I get this final factorization. And y equals to this is less than or equal to 0. And therefore, if you graph it, you get this part. And then this 0 here is -2/3. That 0 over there is 5/4. 2 x-intercepts, -2/3 and 5/4. You can see those from here. And the middle interval goes like this. The original problem is semi-inequality. greater than or equal to, so we have brackets, not parentheses. Let's see. Do I have full problem in the same viewing window? Okay, here we go. This kind of problem is pretty good because it forces all the students to review what you did in linear equations in chapter 1. Breaking up parentheses and breaking up parentheses and taking like terms. That's basically what I'm talking about. And then factoring non-mode polynomials. A lot of reviews in the same problem here. Okay, maybe one more problem, maybe two more, we'll see. How about this problem? Okay, no parentheses, no like term, so you can just go ahead and factor. 12 times 42, oh, that's too humongous. Maybe there's a better way. Indeed, everything is here is even numbers, so you can divide everything by 2 and then make the problem a little bit simpler. So factor 2 out and you get a little bit simpler version here, and then you can factor like this. If you prefer some other method, not tic-tac-toe method, that's fine. Use whatever method that you like to use. In any case, this thing is greater than or equal to 0, so graph it. I want y coordinate value greater than or equal to 0 here in the left and here in the right. So this interval or that interval put together. Now what if we cannot factor very well? Still, you can use graph method. Just graph it. And then I want this thing to be less than 0, so y coordinate is less than 0, we want this part. And if I find this point and that point, this 0 and that 0, I can express it as a solution. Now, how do you find these two zeros? F of x equals to 0, solve one equation instead. So here we go. You cannot factor it with integer coefficients, but you can still set up the equation and solve it using square root. And once you solve the square root, with the help of graph, you can get the interval. One more problem? Okay, alright, one more problem. How about this? You cannot factor it, but you can still graph it. And then you're looking for this x in a set and that x in a set. How do you get that? By setting this f of x equal to 0, and that's a quadratic equation, so you can solve it through quadratic formula. A bit tedious, but you can solve it like this. 1 minus square root of 10 over 2, and 1 plus square root of 10 over 2. So from here to there, and I want the left-hand side and right-hand side, so negative infinity to 1 minus square root of 10 over 2, 1 plus square root of 10 over 2 to infinity like that. So when we don't have integers, it's still okay. Factorization may not be always possible, but it doesn't really matter. Graphs really help. And then once you have those graphs and idea, find out the zeros by quadratic equations or whatever method.